So this is another video for Math 106, and we're going to do 4.1, but first we're going to do inverse functions. So what does inverse function mean? We're going to use a certain process of steps that we're going to use to define the equation. So the steps that we use, and it's always in a one-to-one function. So as we previously stated in class, this means it's a function that passes both vertical line tests and the horizontal line test. And so we have a total of 5 steps to solve for the inverse of a function. So our steps are as follows. Steps. So the first step is to replace, so switch f of x with y. So you're going to switch these two. And then the next step is to exchange x with y, so they flip. The third step is to solve the equation for y. Solve for y in terms of x. And then replace, the fourth step is to switch f of x, or y, to switch y for the f to the minus 1 of x. And the last thing is to verify your solution. Showing that f to the minus 1 f of x is equal to x, and f to the minus 1 of x. But usually when we're solving these, we focus on the first 4. So let's do a couple examples of this. So I'm going to do one from the textbook again and walk through it. And then I'll do a couple of examples based off of the homework. So let's do this one. Let's do example 5. I believe it's example 5 in your book. So it'll be f of x equals x to the third plus 4. So again, what I want to do is my first step is I want to exchange my f of x with y. So that means it's going to become y equals x to the third plus 4. That's the first step. Second step is to exchange x and y. So that means my x is going to be here and my y is going to be here. And then I want to solve for y. I want to get y by itself. So how can I do that here? Well, an easy way that I can do this is I can move the 4 to the side to isolate y, right? So that means it's going to be x minus 4 equals y to the cubed, or y to the third. So this means when I want to simplify the y, I have to cube root the y. So that means there's going to be a 3 in front of my square root. So it's just y equals cube root x minus 4. So we're pretty much done. We've isolated y, and now we know that f to the minus 1, I'm just going to change it. So I know f to the minus 1, you're exchanging that y for the f to minus 1, equals cubed root x minus 4. Let's do another one. So let's try a little bit harder. So let's try this one. F of x equals 3. Let's turn this on to do not disturb. 3 over x over 1. So again, we're going to follow our same steps and this was 4 here. So we have 1, exchange the f of x to y, exchange x and y, now the next step is to solve for y. Now there's 2 ways on how you can solve this. You'll still get the same results. I will show the way that your professor taught you, and then I will also show the way that my professor taught me. So his way is taking the least common denominator here, multiplying it by this, and so now this eliminates these 2, and then you're left with y minus 1 x equals 3, right? So then we just do this distributing. So xy minus 1x equals 3. So now I want to get y by itself. So how can I do that? Well, you can divide everything by x. And that means also the other side will also be divided by x. But am I in the right setup? Because I want to isolate, let me backtrack. So I want to isolate the y, right? Well, how can I do that? So let's see. Oh, what I can do before I even try to get rid of the x here, I can move this 1x over to the other side. So it's xy equals 3 plus 1x. And now we can isolate that x out. So then we're left with y equals 3. You can see, you could say plus x over x, or you can leave it the way I did it. Either one is fine. Now, another thing is, if I go back to the third step when we started out, I can actually show this a different way, too. We can cross multiply. So let's go back to the second step, and then I'm going to solve it the other way. Let's show another way. So another way you can write this is you can make the x be under 1, and then you just cross multiply. So both ways will work. 3 equals x y minus 1. You see we have the same setup. Oops, 1x. I move the x over. 3 minus 1x equals xy, divide by x. And you still land up with the same answer. But are we done? So yes, we got the same answer, but on the next step, am I done? No, I still have to do the last steps. That means number 4 is I have to do f to the minus 1 equals 3 plus x over x, or either one will be fine. Oops. So both answers will be correct. So there's 2 ways you could technically do this, but of course, if the LCD, using the LCD method like we did in the previous section is easy for you, just do that. I just wanted to show both ways. So let's do another one similar to this one. So let's do, this is going to be one similar to the homework, so f of x. So what I want you to do is for this one, I want you to try solving it on your own, and then we'll come back. So I'm going to give you a few minutes to work on this. Okay, welcome back. So let's go ahead and do this example. So again, my first step is to exchange f of x with y. So that means it's going to be y equals x over x plus 10. And then I want to exchange x and y. And then solve for y. So let's just focus on using the LCD. going to go away on the right-hand side. I'm just going to write it like this. Distribute. And then I want to get that 10 on the other side. But since I already have x on one side, I actually want to change this. So instead of moving the 10 to the other side, I'm going to move the xy to the other side to get all the y's on the same side. So let's try that. So 10x equals y minus xy. So now you can see how they're both on the same side. So I want to move the variables to the side where they'll be more likely to be together. So now what can I do? Well, an easy way to simplify this is to factor out the y. So that means when you factor out a y, the y gets taken out. So it's y, and then what's left behind is 1 minus x. So there's a 1 that replaces the y position, and the x is what's left behind. And then you get 10x. And then what? Well, I want to get y by itself, so what I'm going to do is I'm going to divide the 1 minus x out and move it to the other side. So y equals 10x over 1 minus x. And then I switch the y with f to the minus 1. So I think what the tricky part of this one in particular was knowing how to factor out the y in this step here. So again, to go over that one more time, how I do that is because I have two y's. I factor out the y here, and then the 1 takes that y position, subtract minus x, and then you get 1 minus x there. And that'll be the same every single time when you factor out. Okay. So let's see, do we have any more examples? Let's try this one. Let's try f of x square root 4x minus 5. So I want you to try this one. Okay, welcome back. So again, we're gonna do the first step. We're gonna exchange f of x with y. And then we exchange x and y. And then what will happen next? So what do we always do when we try to get rid of, because we want to get rid of that square root. So what do we always do is similar to what we did with solving for radicals. So the thing we always do is we square both sides. And that gets rid of my square root. So then we're left with x squared equals 4y minus 5. Okay, now we see we have a regular quadratic setup here, but we're not gonna solve in that way. We just want to isolate for y. So what I'm gonna do is I want everything on the opposite side of y. So how can I do that? Okay, well I want to put y over here. I want to have x over here. So I'm going to move it. So I did was just flip it. And then what's going to happen is we're going to divide by 4. And then we get y equals x squared plus 5 over 4. So that means the last step, so this was 3. The last step is to exchange y with f to the minus 1 of x equals x squared plus 5 over 4. And then if we were actually to talk about the range here, the domain and range, so let's see. Let's let an example of this. So if a square root of a function can never be negative, so the range would be f of x equals 0 to 1,000, or 1,000, to infinity. And that also means that since our domain, f to the minus 1x, will just be the opposite of that. So this is our range. This is our domain. So they'll actually be the same. Just a short little thing there. All right, so now let's see. Do we have any more examples that I can do? Let's try this one. So f of x equals negative 3x to the 5th minus 5. So again, we did step 1, exchange f of x with y. And then the next step is we exchange x and y. So x goes here. Well, now what do we do? Well, I still want to get x away from y. So I'm going to try to get y isolated. So I'm going to move this 5 over. And I still want to isolate more. So how I can do that is I can divide by 3, negative 3. And then we're left with this, because these go away. But then how do I get rid of the y to the 5th? Well, that means I have to square root both sides by the 5th. So we can also write this form in the exponential form, which your homework is probably going to want it to be written as. So we're going to change this square root to being like this. But another thing too is your homework actually might want it in the other form, factored out. So what does that mean? So we want to put this into the factored form. So let's do like a breakdown on how to do that. So factoring out, we want to factor out the negative on the bottom. So that means if I do this example, a plus b over negative c equals, now we're going to move that negative to the top. So that means that negative gets distributed into the a plus b. So if we do that with this example, let's do x plus 5 over negative 3. When that gets factored, what's going to happen is it's going to be like this. So that negative gets moved to the top and distributed. So it becomes minus x minus 5 over 3. And that's how they might have you rewrite it here. So this is technically correct if you get this, but the other form of it that's equally equivalent to it is this. And then we put that into the f to the minus 1 form. On an exam, you're not going to have a problem like this, but I wanted to at least give one as an example for your homework, because it might say you're wrong, but technically you're right. It's just you're showing the opposite form of that. So then let's do the last one. That was a classwork that you had. This is a really great example because previous exams have used a problem like this. So we want to do an example like this one to make sure that you're understanding. Because if you see this on the exam, I want you to be able to solve it. So if you can, take a moment and try to solve this to make sure that you're understanding. Because if you see this on the exam, I want you to be able to solve it. So if you can, take a moment and try to solve this on your own, and then come back and see if you got the right answer. And of course, if you've already done it, then great. Okay, welcome back. So first thing, step 1, exchange f of x with y. And then exchange x and y. Now I want to solve. So I'm going to use my LCD. So this guy is gone. Technically, I should have not written that. So now we're left with the LCD being on the left-hand side only. And now we can distribute that x into the LCD. So you get 5xy minus 7x equals 2y plus 3. So now I want to isolate my y. So I want to move my y over here, and I want to move my 7x over there. So we get plus or minus 2y okay. Now you write the plus. And now I want to move the x to the other side. So how can I do that? Well, if we go back to what we did before, is we factored the y out. So I'm going to take the y out of the whole thing here. So that means it's going to be y equals 5, or y parentheses 5x minus 2. So you just took the y out. And now I want to get the y by itself, so you just divide 5x minus 2 and move it onto the side. So you're left with y equals 7x plus 3 over 5x minus 2. And we just exchange that, so that was the third step. Now we're done, and now we exchange it for the fourth step. 5x minus 2. So most likely you'll be given. So if there's a problem in your classwork, that is most likely what might be on your exam. So I would, if you can, each time you go through reviewing for the exams, go back through the classworks and try to do all of those problems. And if you get tripped up on the problems, you can do them over and over and find out where you're getting lost. So this is the inverse, solving for the inverse of a function.